And just like chapter 6, we had lots of solving. I hope you see that chapter 6 and chapter 7 have a lot of oral. Right? In chapter 7, the identities part, the proving, was completely new. But solving was a big part of chapter 6, and it's also a big part of chapter 7 as well, solving for theta. But now it gets more complicated because now in solving questions, we might have identities that we need to use. We used some of them already in chapter 6, like sine squared theta plus cos squared theta equals 1. But now we're going to have some more and re-look at those as well. So what we're going to do is we're going to write down some strategies. Then we're going to look at different questions and see how we can use those strategies to solve them. So I'll get you to write this down first. And there's our first question. So in solving for theta here, okay, it is a solve question. The strategies that we're going to use, all right, sorry about that. The strategy that we're going to use in this situation, which is kind of like a strategy that you're going to use in identities, is if you don't know what to do, it's not bad to change everything to sine and cosine and problem solve from there. So even though I'm solving, currently I cannot solve this because I have a cotangent and a cos. And it is impossible to solve something if you have two different trig functions. Now there's no way to change cotangent to cos or cos to cotangent directly. So sometimes we just say, I will change everything to sine and cos. So cotangent is cos theta over sine theta. And then it's a solutions. It's not a proof. You are allowed to do things on both sides. So we are going to multiply both sides by sine theta because that gets rid of fractions. Right? And the next place is a place where it's really easy to make a 1-mark mistake. Because it would be really nice to just get a sine theta. And you can probably easily see, hey, if I divide both sides by cos theta, it goes away, and I just have sine theta. And that seems like a great strategy. So we're going to put off to the side a little note. If you are tempted to divide, and this should be like, doesn't seem like dividing by cos would be really nice and make this a lot simpler. Okay? Yeah, it's a great idea that loses you a mark. Why does it lose you a mark? Because if you're tempted to divide, it might be that cos theta equals 0 is a solution. Can you see if cos is 0, this side is 0? And if cos theta is 0 on this side is 0? Is 0 equal to 0? Yes. And if you divide by cos theta, you accidentally divided by 0 without knowing it. And you're not allowed to divide by 0. So if you are tempted to divide, factor instead. So what does that look like for us here? Well, in order to factor something, and in order to use that factoring to help us solve, I need to make one side equal to 0. So instead of dividing by cos theta, I factor a cos theta out. And that still gets us this solution that cos theta could equal to 0. And you still get the other solution of sine theta is equal to a half. When is cos theta equal to 0? On our pi plate, that's at pi over 2 and 3 pi over 2. When is sine theta equal to half? That's our pi over 6 family in quadrant 1 and quadrant 2. I got into normal mode where I solved between 0 and 2 pi. So I should always take the time to go back to the original question and read. And because I made the question, I made it between 0 and 2 pi. So everything is good. But it might have been a general solution where you have to go plus 2k pi to everything. Or it might have had a different domain. So it's still very good practice for us to always check which one it was. Okay? So in our strategies, right? In our strategies here, we used the one where we changed to sine and cosine. We got rid of fractions. And we had to factor in the end. All right, next set of ones that we're going to do. So continue on page 666 if you have room, but you can continue on page 667 if you've already used that up. Remember multi-revolution questions when you had a 2 theta or a 3 theta? Well, sometimes when you have a multi-revolution question or a 2x, sometimes it's a multi-revolution question, but now sometimes you're going to have to use one of your double angle identities. So we're going to look at how do we know which one to use and when. Okay, so first of all, both of these questions have a 2x inside either sine or cosine. And up till now, the only time we've seen a 2x inside sine or cosine was only multi-revolution questions, so your brain could only think about that. This is the problem about learning more. When you learn something more, you make something that was previously the only thing you had to think about now more difficult because you have choice. When you see a 2x, it's either going to be a multi-revolution kind of question that you can solve that way, or it might be that you have to use your double angle identity, so you have to make a choice. In this most simplistic way, the only way you can do a multi-revolution is if this is the only trig function in the question, which it is in this example. If you have another trig function, then the strategies of multi-revolution do not work, and you'd have to try a double angle identity. So first, we will review multi-revolution questions. So in this question, we would get cos 2x by itself. Move the root 3 over 2 over the other side. We rewrite our domain for 2x. So our domain was between 0 and 2 pi. Now 2x would be between 0 and 4 pi. And we solve for 2x. Well, root 3 over 2 is on your pi plate. That's part of your pi over 6 family. Pi over 6 family in quadrant 1 and in quadrant 4, because that's where cos is positive. Second time around, and just a reminder, how do we find that second time around? Well, the second time around, it's going to be coterminal with the first time around. So I have to add 2 pi, but how do I add things with fractions? 2 pi with a denominator of 6 would be 12 pi over 6. So notice from pi to 13, I just added 12. And from 11 to 23, I just added 12. Because I'm adding 2 pi to get the coterminal spot, but I need a common denominator. So 2 pi becomes 12 pi over 6. And then those second time around become easy. Now to find our final answer, we divide each of them by 2, which is the same as multiplying by a half. And we get our 4 answers. On the other side, we have the double angle, but we have another trig function, so we have to use our identities. Now, sine 2x only has one option. Look at our formula sheet. Sine 2x is 2 sine x cos x. I make that change. And right here, again, can you see that you could get rid of the signs if you divided? But if you're tempted to divide, we should factor instead. So I will first and this idea of factoring, it comes up on that first take-home quiz that I gave you. It's either in the first one or the second one. So sine x could equal 0. Cos x is equal to half, 0, pi, and 2 pi. For cos, quadrant 1 and quadrant 4, because it's positive, pi over 3 and 5 pi over 3. Double check our domains. They were between 0 and 2 pi, so we're good that way. Yes?
Why would you put it as negative sine x and not just take why would you just take the 2 off the sine x and make it sine cos x equals 2?
When I'm subtracting here,
Yeah.
this and this are not like terms, right? And so it's interesting. As soon as we make things a little bit more complicated looking, then our brain loses some of those like basic rules that we've had since grade 9. I can add like terms, but here it's sort of like, why don't I have 2 sine x's? Why don't I just subtract 1 and make 1 sine x? It doesn't work that way because this whole thing is a term, and it's not a like term with that other one. Okay? When you see, this is a great thing, when you see things like that, that you're like, could I do that? Why can't I do that? Those are great questions. Because if you're wondering it while you see it in the notes, for sure you're going to wonder it when you're all alone on a test, right? That's, like if you wonder it now and push it away, guarantee that thought is going to come back when you can't ask a question. So it's great to ask those questions now, and the explanation is like, oh, that makes sense, and you won't have that problem. But I guarantee on an exam, when you're like second guessing yourself, you're like, well, that would make it easier, why don't I try that? And then it goes bad. Okay, excellent. So we'll have, now we'll go to the example in the textbooks on solving question number 4. Solve this equation. I noticed a double angle. So I asked myself, should I use my identity or should I do this as a multi-revolution? And sometimes we can memorize strategies, but sometimes we forget strategies because we didn't quite memorize them. Then we have to problem solve, right? Problem solving, if you forget which way to do it, is take out a piece of scrap paper and try something. And if it doesn't work, put that piece of scrap paper aside, take out another piece of scrap paper, try something else. If that doesn't work, maybe you go back to your first scrap piece of paper and say, I should try that again, but I should try it slower in case I made a mental math mistake. Because maybe it was the right idea. This is the worst thing that happens in math. You pick the right idea, but you make a little tiny mistake while trying the right idea, and then be like, oh, it's wrong, and crumple it up and throw it away. And then you spend the next, well, I was going to say 2 weeks. You would probably only spend 5 minutes. 5 minutes trying another strategy, nothing else works, so you say, oh, it's impossible. But sometimes we do have to go back to a first strategy we tried and say, I have to try it again slower, because maybe I made mistakes with it the first time. This one has a double angle, but since it does have another trig function, I am going to use my double angle formula and the 1/2 and the 2 will simplify nicely. So I could be tempted here to divide. So I'm going to notice that there's a common factor. I'm going to factor that again. But unlike the other questions that we've had so far, on the other ones when we factored, it was nice because they separated the sine and the cosine. On this one, when we factor, the cos is nicely separated, so I know that this is an answer. Cos x is equal to 0. But the other one, there's still a sine and a cos. What would make this 0? This would be 0 only if sine x was equal to cos x. Does that make sense? So how do we solve that part? I can change sine squared theta to cos squared theta with sine squared theta plus cos squared theta equals 1. But if they're not squared, you can't use your Pythagorean identities. So what do we do in this situation? Well, first of all, let's go to this side and say, this is easy. I can solve that one. And if I can't solve the other one, at least I'll get 2 out of 3. Not bad. Okay? The second one, if we use some problem-solving strategies, and we think, is it ever possible on my pi plate that sine theta can equal cos theta? Yes. Quadrant 1, they're both root 2 over 2 and root 2 over 2 at pi over 4. Is there any other place that they're identical? Quadrant 3, where they're both negative. So you could solve this one quadrant 3 is 5 pi over 4. You could solve this one just with your pi plate and saying, can they equal each other? Yes. You could also solve this one by dividing both sides by cos. And you might ask yourself, but before dividing by cos might be bad, because it might equal 0, and it does equal 0 in some situations. But for this solution, if cos is 0, sine can't be 0, so it's not a solution for this one. And if I divide both sides by cos, sine x over cos x is tan x, and that's on your pi plate. And when is tan x equal to 1? Well, that's at pi over 4 and 5 pi over 4 as well. So 2 different ways of getting that pi over 4 and 5 pi over 4. One, just by observation from your pi plate. But you could also change this to tan and solve it that way as well. Okay, now, I have a lot of questions for practice on this, because this is like solving for theta, both the identities and trigonometry combined. They're 2 of your 8 units, which is 25% of the course according to units. But I would say that about 30 to 40% of the exam is based on these 2 units. So they're their biggest 2 units. So we do need to practice a bunch of questions. So, from your textbook, circle questions 12 to 15. And the same identities worksheet that I said you need to study questions 20 to 43 for your quiz on Monday. Okay, on the back side there was a bunch of questions to solve, and I want you, there's some circled, but they're not the right ones that are circled. So highlight the following numbers: 8 and 9, 11 and 12, 14 and 15, 21, 27, 29, and So lots,
Those are the ones you want us to do.
Hmm?
Those are the ones you want.
those are the ones I want you